For the book assignment, number 23 for your upper, you should have got 16.5, your lower 12.5, and an average of 14.5 units squared. 24, 16 for your upper, 10 for your lower, 13 units squared. 25, 11 for your upper, 7 for your lower, 9 units squared. 26, 9.25 for your upper, your lower 4.25, average 6.75 units squared. 27, your upper is 0.76825, your lower 0.51825, average 0.64325. For 28, you should get an upper of, this one is a crazy decimal, 8.3215, and a lower of 7.9665, and an average of 8.144 units squared. 29, your average is 0.6955766 units squared, and 30, your average is 0.75924 units squared. All right, for the worksheet, for number 1, you should get an average of 18.125 units squared. For 2, 9.5 units squared. For 3, 17.26 units squared. For number 4, you should get 7.32 units squared. For 5, 2.685 units squared. And for the last one, 3.45 units squared. All right. So, with that being said, let's learn how to do this without those crazy boxes. Okay? So, what you guys are doing are called definite integrals. You are finding the area under a curve. So, a definite integral tells us the area under a bounded region. Before, you guys were finding this, and you would find the antiderivative, so you get 3x squared over 2 plus 4x plus c. Well, we're going to continue to do that, but now that it's a definite integral, we're going to be able to find the area. So they're going to add something here and something, and we'll do that. So we got to learn some properties first before we get too excited. So here's our properties, and they're really hard to read on the screen, so you might need to print out the notes. So our first property is saying it's going to have little letters on the definite integral now. And what those little letters or the numbers mean is that's the interval that you're finding the area from. So we're going to find our area from A to A. So that means like we're finding the area from x is 2 to x is 2. So that means your area is 0. This one's saying if you find the area from B to A, then it's the same as finding the area from A to B, but putting a negative in front of it. So B to A is the opposite in sign as A to B. Here it's saying if you find the area from A to B, and maybe you wanted to find the area from A to C, and C's in the middle or somewhere in between A and B, and then you find the area from C to B and you add them together, you'll get your area. This one's saying if you have a constant times your function, you can move that constant out, find the area, and multiply it. This is just saying if you have two equations added together, you can find the area of one, add it to the area of the other. So let's try some examples. So I would probably print off the notes page, that way you can have these notes, because they are very hard to see. So this page is also hard to see, so you might want to print it off as well. So it says if from 2 to 6 your area is 10 in one function, and then from 2 to 6 your area is 3 in another function, let's use some of our properties. So our first function, our area from 2 to 6 was 10. Our second function, our area from 2 to 6 was 3. So this is saying from 2 to 6, what's the area of the first function plus the second function? So what you should do is just add your areas, and you get 13. You're done. This one's asking, what's the first function minus the second function's area? So you simply subtract your areas. This one is saying if I take 2 times my first function minus 3 times my last function, what do I get for an area? So we're going to take 2 times 10 minus 3 times our last function and get an area of 11. On this one, it says, what if I take 5 times my first function? What would its area be? So we're going to take 5 times the area of the first function and get 50. And you're done. So basically you're just doing the operation that it says in between there. So let's try a different example. This is saying if we want to find the area from 2 to 6 of x to the 4th, its area is 1,548.8. If I want to find the area from 2 to 6 of x squared, its area is 69 1/3. If I want to find the area from 2 to 6 of just dx, that's 4. So it wants me to find the area from 6 to 2 of x to the 4th. So that one's pretty easy. All you have to do is put a negative sign in front of the original area and you're done. Because it went from 6 to 2 rather than 2 to 6. This one says, find the area from 2 to 6 of 5x squared. So they took a constant times your x squared. They took 5 times it. So we're going to take 5 times x squared's area of 69 1/3, which is 69.3333 on there. I'm going to write it as 69 1/3 to be exact. And you get 346 2/3. Alright, this one's saying from 2 to 6, what's the area of 12 dx? Okay, I have x to the 4th, that doesn't match. X squared, that doesn't match. Then I just have dx. This one has 12 dx. So I'm going to simply take 12 times that 4, and I get 48. Alright, for the bottom one, we got from 2 to 6, we got x to the 4th plus x squared minus 3. So x to the 4th's area was 1548.8. X squared, they want us to add on. So we're going to add on the 69 1/3. Then it wants us to subtract 3. But it doesn't want us to subtract just 3. It wants us to subtract 3 of that function. So we got to take 3 times our 4 area to get that. Because this isn't area, that's a function that they want us to take times 3. So we got 1548.8 plus 69 1/3 plus, or minus, 12. And you get 1606.13 repeating, which as a fraction, they didn't give it to me. So, that is it for these notes. Please come with questions for next time. Yay, go you!